All right, everybody, let's get started with lecture 22 in week 12 in Engineering 102. We are rocking and rolling, and we are going to be finishing this class up sooner rather than later. We're going to be spending the rest of the semester utilizing Autodesk Inventor. Okay, we're not spending a lot of time, we're only spending 4 weeks on Inventor, but because of our investment in AutoCAD, what you're finding is we're going to move through Inventor. We're going to move through it very, very fast because I'll say between AutoCAD and Inventor, I think it's very fair to say that AutoCAD is the more challenging of the packages. I think Autodesk Inventor is easier, and there are things that you need to do in Inventor that we already know how to do. So for example, one of the first things that we'll learn how to do when creating a 3D part is to do what's called an extrusion. So you take like a 2D sketch, like if you wanted to create a box, like a three-dimensional prism, draw a 2D rectangle and then extrude it out. Well, we already know how to draw a 2D rectangle because we've been drawing in 2D for the past 8 or 9 weeks. And since they're both Autodesk products, a lot of the commands are going to be very similar. So we're going to move pretty quickly through Inventor, but we're going to be able to do a lot with a very little bit of time. Just a couple housekeeping items. Number one, for attendance, I actually had my survey code up, which I usually give at the end of the semester here a bit ago. So if you clicked the attendance code and it pulled up a survey, click this one instead because I just want to make sure you get I get your attendance log for today. So if you missed the attendance code, please go ahead and get that now. Because of when we reorganized our homework assignments because of the weather and whatnot, I wasn't sure what averages I had reported to you, so I just said, here they are. Other than the exam, everything that's outstanding has been graded, including your assignments and the attendance. Attendance is up to date, obviously, other than today. You don't have any outstanding homework because I'm going to give you your first Inventor assignment on Wednesday. Next week, I'm going to be assigning your final assembly homework in Inventor, and it's going to be due during finals week. So I'm giving you a little bit of time to work on it. Not that it's some demonstrably huge assignment, it's just I'm giving it to you early so that you have it. So we're going to have a homework assignment this week. We're not going to have a homework next week. Because next week we're going to go through and do some of our remaining Inventor exercises. Okay, everybody good so far? Okay, and everybody got the code? All right, so let's get to it. Let's talk a little bit about Inventor. So first off, hopefully everybody's got Inventor installed. Again, if you're running an Apple package or an Apple computer, the only way to access Cameo is either through partitioning your drive with a Windows partition or using Cameo. There's really no other way to do that. But for you Windows folks, shouldn't be a big deal. Let's talk a little bit about Inventor. Okay, so if the name of the game in AutoCAD was 2D, the name of the game in Inventor is 3D. And I want to be clear, AutoCAD can do 3D as well, but I don't really even think that Autodesk would disagree with what I'm about to say. But AutoCAD was originally a two-dimensional package, and 3D was, I don't know if just added on would be the best way of putting it, but Inventor was initially conceived as a three-dimensional modeling tool, so it does work a little bit better in that regard. One thing about Inventor is that I would say that if AutoCAD is meant for computer-aided drafting, Inventor is meant for computer-aided design. Okay? I'm not saying that you can't use AutoCAD during the design phase. You can, but AutoCAD and Inventor have slightly different purposes. Like Inventor is meant to be used more integrally during the design phase, so it does operate a little bit differently. Inventor also has a lot of additional features besides just basic geometry creation. In other words, in AutoCAD, all you're trying to do is draw stuff. And that's not to say that you can't do that in Inventor as well, but you can do a lot of other things too, like stress analysis, which we'll do near the end of the semester. But because they're both Autodesk products, they do have a lot of the same commands and the different ways of doing things. And we can also take AutoCAD or Autodesk Inventor drawings and export them and use them later in AutoCAD and whatnot. Okay, let's talk about the file structure because you're going to be saving files and uploading files. And this is really important for your final assembly because your final assembly, you're going to have to upload 10 different files. Okay, so I want to make sure that you've got everything that make sure that you understand what you're doing. So the thing I want to differentiate in Inventor is between the idea of a part and the idea of an assembly. Okay. So for example, so those are the two main file types we're going to be dealing with: are parts and assemblies, and they each have different purposes. So how many of you, for example, have gone to Walmart and bought one of those like particle board entertainment centers or shelves or whatnot and built them, you know, like drawers, tables, what have you, right? So let's say you have like a table that you bought, okay? And the table consists of, let's just keep it simple, one surface and 4 legs, okay? So that's a total of 5 parts, right? But really, the 4 legs are all the same. Like it's the same part, you just copy and pasted the thing, right? So the idea is that in Inventor, we would have a single part file for the top of the table, and then a single part file for the leg, right? But then the assembly is going to have 1 instance of that tabletop and 4 instances of that leg. So the same part just used over and over again. So the part is each unique component of whatever it is that you're trying to fabricate, and then the assembly is the collection of all of those things together. And the value is that you can repeat things over and over again. So if you have like bolts that were used over and over again, screws that were used over and over again, an assembly makes that kind of nice. Did everybody get a handout? Okay, don't be shy, but come on up here if you need a handout. Come on up here and grab one. So I notice like people coming here and there. Everybody come on, don't be shy. Okay. All right, so as you're working through Inventor, this is what Inventor looks like. There are a lot of things that have a slightly should be familiar feel than what you see in AutoCAD. For example, you see a ribbon up top, and there are several options on those ribbons that you can then select and do things with, you know, sketching, annotate, things like that. But there are some key differences between AutoCAD and Inventor. For example, there is no command line. There's no command line in Inventor on the bottom like there is in AutoCAD. You also see something there on the left. It's sort of like this window here on the left, which I'm going to call a model tree. That's going to be kind of important as we utilize different facets like drawings and assemblies and things like that. But for now, I would just say that hopefully the vast majority of this interface looks somewhat familiar. Let's do through a quick tutorial, and some of that I'm going to talk a little bit first, and then we'll go through our in-class exercise together on how to use Inventor. Okay. So what we're going to be doing today is, in my opinion, the best way of learning how to use Inventor is to just sort of dive in and do it. So this is the part that we're going to create together. Much of what we do today. So we're going to go through some really basic commands today, things like unions and subtractions and things like that. But if you know how to do this, you can probably do about 70 to 80% of anything that you would need to do in a modeling project. I am a fan in both AutoCAD and Inventor in not showing you how to do literally every single command. I think what's more important is that you master a few commands. Okay? If you understand how those few commands, but those really important ones work, you'll be much more powerful in modeling things to come. So this is the part we're going to model today. Now, I'm showing you how to do this in Inventor, but it doesn't really matter. I mean, it could be Inventor, it could be NX, it could be SolidWorks, it could be Pro-E. Any 3D modeling program is going to essentially operate the same way. Like, I'm teaching you how to model things in Inventor, but ultimately the skills that I'm imparting upon you, you could use in other packages. Okay? The two general approaches that I would kind of like to discuss with you is, first off, like the carpenter's approach and then the Play-Doh approach, and you'll see what I mean. So the idea behind the carpenter's approach would be to start out with a shape and then cut away the sections that are not needed in order to generate your final product. So for example, I could start out with a big old block of wood and end up with that, okay? The flip side to that would be more like an extrusion type approach, like for example, what I'll call a Play-Doh approach. I imagine you all have seen stuff like this in the past. So the idea is, you have some sort of two-dimensional cross-section that you then extrude to some specific depth or some specific height in order to generate a three-dimensional part or feature. All right. So we're going to be using a little bit of both today in order to generate a given part. But I think what's most important is that, you know, you need to sort of be familiar with both as you're going through a given project. You know, you're not really going to be told, model it this way, draw it that way. You're going to have to figure that out, especially if you're the engineer designing it. Nobody's going to be telling you how to do that because you're the one telling people. So you kind of need to be familiar with both, okay? Now, there is one thing, though, that is probably the most difficult thing to get used to when using Inventor, and the idea is dimensioning, okay? So this is like one of the biggest differences between AutoCAD and Inventor, and something I kind of need to break you of right now, okay? So in AutoCAD, if I asked you to draw a line, okay? Everybody in here could draw a line, but literally the only words that came out of my mouth were draw a line. I'm going to get 60 different lines, right? Okay? And without giving you that specificity up front, that the line is 5 units long, that it's oriented in this direction, that it's on this layer, I'm going to get 60 different answers, right? Okay? The idea in AutoCAD is that you must know the specifics, you must know the dimensions, you must know the geometric parameters prior to drafting, prior to modeling. That's not the case in Inventor. In Inventor, you can sketch things out kind of roughly and then apply dimensions later to add specificity. So for example, if we look here on the slide, the bottom right image is what I'm after, this L-shaped cross-section that has very specific dimensions. The thicknesses of the legs are 0.75 inches. The out-to-out width is 2.5 inches by 2.5 inches, okay? But I don't need to know that before I'm drafting. What I can do is start by drafting this thing on the top, top right, and this thing on the top right is just this generic L-shaped looking thing, and then I can dimension it later, okay? That is something you do have to get used to in Inventor, the idea that you can dimension later, okay? But again, Inventor is meant to be used more in the design phase, whereas AutoCAD, by all measures, is sort of meant as a documentation of your be-all, end-all final product. This is more about the conceptualization stage, but you can use it for final documentation as well. Okay, so I want to start off with with Inventor. Okay, so I'm going to open Inventor right here. Okay, so a couple things. Everybody got their hand out so you can follow along with me. But the first thing I'm going to do is create a part here. Okay, so let's go to New. All right. Now, a couple things, and I don't think I was actually very specific on this assignment because it doesn't really matter. It's going to matter later. But if you look here on the main window, okay, so you'll notice we have several templates. We have English and metric. We have parts, assembly, so on and so forth. I believe it defaults to English units. And so I don't, actually for this, I don't know that it really matters if you use English or metric, but I'm going to use English, and I'm going to do a standard part right here. And so it says standard IN, and it's part up here. So you can see parts here, assemblies there. We're going to do a standard part in inches. And so we'll hit create. Okay, and so Inventor, I'll say this, one thing you might notice with Inventor is that it may run a tad slower on your machine. It's probably running a little bit slower on mine, but that's okay. All right, and so it's pulling everything up. And then what we're going to do is we're going to save this. I'm going to save it as tutorial 12. File, save as. I'm going to put this on the desktop. For those of you using Cameo, make sure you save it in the X drive in the MS folder, not the OneDrive folder, the MS folder. Okay. Okay. So your Inventor environment should look something like this. You might have sort of this like blue hazy background. I've made my background white to give it a little bit more contrast in us seeing it here on the screen. Okay. But yeah, so the first thing that we're going to do is try and get used to this notion of shape before size. The idea that we can roughly sketch something out and then dimension it later. Okay. So what we're going to do is we're going to start off with our part by creating a 2D sketch and then extruding it. Okay. So what I'm going to do is I'm going to start off by creating a 2D sketch. So if you look in the 3D model, 2D sketch, and then this thing pops up, okay? So basically what it's asking is, okay, you want to create a 2D sketch, where do you want to start, okay? So if you highlight, you can see the various planes. So for example, this is the YZ plane. This one is the XZ plane. I'm going to start off XY, okay? I think that's probably what we're most familiar with from math, like the XY coordinate system. So we'll click the XY coordinate system, and then now look at the ribbon up top. Now we can see lines, circles, arcs, rectangles. Well, I know how to do that. I've been doing that for weeks now. I can draw lines and arcs and rectangles, no problem, okay? So what I'm going to do is I'm going to create a sketch that looks something kind of like this. It doesn't matter how exact it is. It doesn't even matter really where it starts. So let's see, but I'll try and get something kind of, let's zoom it out a little bit. Maybe like that, that, that. Then as you draw it, you should see, for example, these symbols popping up on the screen. So for example, see these little right angle symbols and these little parallel symbols. Those are what are called constraints. We'll talk about that here in a little bit. But generally what you should have is something about like this, okay? I'm going to give everybody a sec on this, see if they're able to at least get a rough sketch that looks something about like this. It doesn't have to be perfect, just close. Yes?
I can't download the Inventor. Like it's not even the option. If you go and click add products. This one.
Yeah.
If it shows only that, it says up here add products. Yeah.
All right, let's do a quick run around, see how everybody's doing on Inventor on the first sketch. Is everybody doing good on the first sketch? Everybody doing good? How about over here? Doing good over here? Doing good? Yeah. I think it's the resolution or it's a small and beside that. Everybody good? All right. Okay, eyes up here. Okay, so now that you've gotten your sketch figured out, this is fine. But what we now need to do is add some specificity to it. Okay. Now again, as you are constructing this, you'll see that Inventor is trying to be intelligent and recognize that, oh, you meant for that to be a right angle. And that's true in this case. We'll talk a little bit later how you can modify and adjust those constraints. And by those constraints, I mean those little symbols that are popping up. But for now, they're helping us out because they're doing exactly what we want them to. But what we do need to do is apply some dimensional constraints. Okay? Now, the way that works in Inventor is, see how you have this little dimension button right here? So we click this little dimension button, and then look right here. See how we can highlight over that red line? And now we can see we can place a dimension right there. Then once we click, it asks us for a value. Okay? This is something that AutoCAD didn't do. And so if I enter in a value of, say, 2.5, boom, now it actually changed the configuration of the object. That's something AutoCAD would certainly never do. But I'm going to keep going with that. I'm going to make this one 2.5. I'm going to make this line here. You might need to zoom in to make sure you're clicking the line. Make this 0.75, 0.75, and boom. Now we have a sketch that is much more geometrically precise. Okay, we didn't have to do that or we weren't able to do that, I guess that's the best way of putting it, in AutoCAD. In AutoCAD, we had to know those numbers first. Now we can just sort of draw this amorphous blob and apply constraints to it later. Okay? Once we're done, we'll hit Finish, Okay, and now we've got this wonderful little sketch, but what are we going to do with it? Okay, let me zoom in a little bit like that. So what are we going to do with this sketch? Well, what we're going to do is we're going to do what's called an extrusion. Okay, so the way an extrusion works is pretty simple. Okay, we click the extrude button, and because there's only one sketch, Inventor kind of knows, okay, you want to extrude everything inside that closed boundary. Okay, how much do we want to extrude? Well, that's really up to us. But for the sake of this discussion, I'm going to use an extrusion of 2.5 inches. Hit OK. Boom. And that, folks, is our first 3D part in Inventor. Okay?
Can you do that again?
What's that? Extrude. What's that?
Can you just show how to do it again?
So all I'm doing is clicking the extrude button. Well, here, let me undo this. I'm clicking the extrude button and I'm changing the distance to 2.5 right here. And while we're at it, I'll say that the mouse wheel works very much like it does in AutoCAD. The idea of scrolling, zooms, double clicking, the mouse wheel and clicking and holding the mouse wheel pane, all those operations are the same. I'm going to give everybody a second on this, and then I'm going to talk a little bit about part navigation. Is there anybody having an issue with the modeling of this first angular part? This one. So that question actually brings up one thing, and we'll talk a little bit more about this later. But everybody eyes up here. I just want to make a point about something. Okay. So one of the things that Inventor will prevent you from doing is what's called an over constraints. Everybody eyes up here. Let me sort of make a point about this. So let's say I draw a rectangle. Okay. And I say that this dimension on the rectangle is 4 inches. And I say that this dimension over here is 3 inches. And then I say this dimension is 7 inches. Inventor's going to get a little angry, right? Because it's a rectangle. It has a length and a width. So if you try and apply more than one constraint, and those constraints have conflicting information, Inventor's going to get angry at you, okay? So typically what you'll want to do is apply enough constraints so that you're fully defining your geometry, and then that's it, okay? And we'll get into that in more detail a little bit later. Okay. Eyes up here because I want to make a point about something. All right, I want to talk a little bit about this up here on the top right. So this little cube that's showing up right here is sort of your navigation pane. Okay, so one of the things that you can do, for example, if I click the little button that says front, it will rotate the part and I can see the front. Okay, if I click these little arrows, for example, that arrow will rotate. I can click that side to be the right. If I click the home button, it will bring me back in an isometric view. So it's a nice little shortcut to be able to rotate the part as needed. As you start modeling things, you're going to have to rotate, okay? You're going to have to change the orientation, okay? Another point worth mentioning is this little button right here. If you click that, it brings up the navigation wheel. So I really want to sort of explain how this works, okay? So see this top part where it says zoom? If you click and hold, it'll zoom. If you click and hold pan, it'll pan. What about click and hold orbit? It'll orbit. What about, bringing it back home and so on and so forth. So that little navigation wheel, and you can close that when you're done. But that little navigation wheel, you can do quite a bit with just maneuvering things around. And so I'm showing you that just so that you can be comfortable with maneuvering things around. Okay. Okay. All right. All right, let me take a second, make sure everybody's good with this. All right. How we doing? So far, so good? Is everybody over here got the first shape created? Everybody good over here? Everybody good over here? All right, eyes up here. So now the first thing that we're going to do, so we have an angle we kind of want to build on top of this. So we're going to create another part and do what's called a Boolean operation. We're going to join these parts together. All right? Okay. Oh, hold on. I got to extrude that. Okay. Now watch this. Now what we're going to do is we're going to do this again. Okay? But what we're going to do is we're going to create another 2D sketch. And instead of like picking a plane, what I'm going to do is I'm going to pick this face. Okay? When I pick this face, what that does is it says, okay, you're going to create a 2D sketch out in space, but you're going to create it referenced off of this face. Okay? And then what I'm going to do is I'm going to draw another angle, and I'm actually going to sort of draw it out in space a little bit, and then I'm going to apply some dimensional constraints accordingly. So let's go ahead and do that. Okay, so there's my angle. Okay. Now let's apply some dimensional constraints. Okay. So let's see what we can do here. All right. Now, what I'm going to do, I'm going to do this one a little bit differently. What I'm going to do is I'm going to basically just apply my dimensions, but I'm just going to accept them as is. All right, but then I've got two more I'm going to do. Okay, so I've got the 4 dimensions that sort of define what the shape looks like. And by the way, you can always just click and drag these things once you've created them. But I've got 2 more I'm going to do. All right, first one I'm going to do is from this bottom corner to the edge. We'll put that like there. Then I've got one more that's from this top corner to this edge. And we'll put that, I don't know, right there. Okay. So I'm basically letting Inventor just sort of accept the dimensions as is, and now I'm going to go in and edit them. Okay. So just so you're aware, what you can do is, once you have a dimension, you could just sort of double click it and say, I want this to be 2.5, and it'll do that. Double click this one, make it 2.5. Double click this one, make it 0.75. And if you're having issues double clicking them, like Inventor's not wanting you to do that, hit the escape key and then try it. It'll work. Okay? Then we'll try this one, 0.75. Now, so I've got my angle sort of the size that I want, but it's not where I want it, okay? And really where I want it is I want it hugged up so that it's actually touching that top corner, okay? And so see those 2 remaining dimensions, that 0.228 and that 0.509? I'm going to double click that, make it 0. Make this one 0. And so now it's right on there, okay? Right on there. Okay. Then I'll finish. And so when I finish, I should have something that looks like this. I should sort of have like the angle, but then I have this sort of part, this sort of sketch hanging out in space. And so what I'll do is I'll do another extrusion. Okay. Now, anybody see a problem? It's extruding the wrong way, isn't it? Okay. Now there's a couple ways of getting around that. You could do a negative extrusion, or see where it says direction. Maybe I'll just flip the direction. But let's look at this properties box a little bit more, okay? Because what's going on here, we've got the different types of extrusion, so we could extrude both ways. We could extrude, top, down, change the dimension. But look right here where it says output and it says Boolean, okay? So we could have join, we could have cut, and we're going to use different ones of these today. But join basically means I'm going to create extrusion 2 such that extrusion 1 and extrusion 2 are now one part. And so when I hit OK, now you can see this is all one big happy family, one big part. Okay? So I'm going to give everybody a sec on this. I'm going to walk around, see how everybody's doing with this. So if the join feature, by the way, creates parts together, maybe the cut feature will remove things like holes and whatnot. So. Yes. Yeah. Just like we did in Autodesk. So when you do your dimension for this, use those as those. Now, hit escape. Get out of the dimension. Oh, like the other. How we doing? I'll do another quick run around and then we'll finish this thing up. That looks different. What's that? So, I have it right here. How we doing? Are you good? Did you say you're good?
No.
You're good?
Can we fix it?
Okay. How are y'all doing? Can we get over here? Over here. Okay. All right, everybody, eyes up here. We all finished? Yeah. Okay. All right, eyes up here. Okay. So now what we're going to do is we're going to try and insert this hole. Now, I'm sure that somebody who's somewhat observant says, well, Dr. Mike, there's a hole command right there. I know there's a hole command. I'm purposefully skipping it, okay? Because while the hole command will give you a circular hole, being able to cut geometries is much more ubiquitous for other geometry creations. So I'm doing this way on purpose, okay? So what we're going to do is we're going to create a sketch here on this plane and do this again, only we're going to cut. So watch what I'm going to do. I'm going to create a 2D sketch right here on this surface. Okay, so here's the surface. And let's just put a circle right there. Okay, now as soon as you place a circle, there's the circle. All right, now we'll get into dimension mode. Now the nice thing about AutoCAD is that you click, it knows you're talking, or Inventor, sorry, I keep saying AutoCAD, but I mean Inventor. It knows you're talking about the diameter, so we'll make a diameter of 0.75. Then now we've got to start placing some linear dimensions, okay? So we're going to place a dimension from the center of the hole to, let's say, this top edge. and that's going to be 1.25. Then we're going to place a hole or a dimension from the center of the hole to the right edge of 0.75. So now the hole is, the circle I should say, is placed exactly where it's supposed to. Okay? Now a couple things when we hit finish, we can see that. Now I want everybody watch this because this is kind of important. Okay? So we're going to do another extrusion, but a couple things. Okay? So first off, that's the wrong direction, right? Needs to go down. Okay? So we're going to change the direction like this. Okay, but here's another thing. Okay? Look right here. See where it says distance A? But look at these little buttons over here on the right. See how this one says through all? Why don't I just click that? Because you don't need to remember the dimension of the other part. You just need the whole to go through the whole thing. Right? So we'll click that. And then for Boolean, instead of join, like if we did join, it wouldn't actually change the geometry at all because we would be joining this hole with the part. The part's already there, so it wouldn't do anything. We're going to do cut, and what it's going to do is remove that geometry from the part. And so if we look, for example, at the top, we can see we now have a hole. Okay? Last thing that we're going to do, and then I'm going to walk around and see how everybody's doing with this. Last thing that we're going to do is this little notch in the corner. So let me show you how we're going to do that. So we're going to do a sketch right here. Let's do a sketch. We're going to do a triangular sketch. And then I propose that the only thing we need to dimension is a length and an angle. So I'm going to dimension from here to here. Going to make that 1. And then I'm going to dimension, so watch this, I'm going to click this line and click 45. So now it knows that if that side's 1 and that's a 45-degree angle, then the other side has to be 1. Now I've got my geometry. Okay? We're going to hit finish. We're going to do another extrusion. Now what I'm going to do is I'm going to flip the direction. And then I'm actually going to rotate a little bit. And I'm going to say, okay, instead of through all, I'm going to click to this little button right there. And when it asks me to what, I'm going to say to this. So I want you to create the notch up to that face. And when we hit OK, now we have our geometry. For those of you that I think have had some experience with either Fusion or Inventor before, you're probably finding this exercise somewhat easy, so that's fine. But if you've never used Inventor before, we're going through this pretty fast. So, but I do want to say that the ability to join objects and cut objects and create basic geometry is going to help you with 70 to 80% of all the modeling that you need to do. If you understand this, you understand the vast majority of what you would need to do in 3D modeling. Okay? So here's what I'm going to do. I'm going to stop my recording, but I'm going to stick around obviously for a little while, and I want to make sure everybody's good with this and walk around and see if anybody has any questions with this tutorial. If you do not, then you should be able to knock out the homework on Wednesday without any issue. So that's all I got. I'm going to stop this recording. I'm going to walk around and see how everybody's doing. So.